Okay, so we're going to be covering 12.3 polynomial long division. And so you did this before last year, or you should have in Algebra 2. I just want to kind of go through that. Right here, this is all the steps. I'm going to let you read that on your own time. I'd rather just kind of jump into it and get to an example. So this right here is excellent to read if you need a reminder. And I'm going to have us actually flip our notes over for just a moment, and I want us to go through the process of like 128 divided by 4. Okay, let's go through the process using an algorithm that you already know. So remember, our first question here is, how many times does 4 go into 1? Well, 4 doesn't go into 1. So then you move on and you consider maybe more digits. So how many times does 4 go into 12? Well, here, 4 goes into 12 3 times. So we put that 3 above the digit that we used, the furthest digit that we used. Once you see how many times 4 goes into 12 and put that number on top, you multiply this to see what your remainder is. So 3 times 4 gives you 12. Then we subtract those and we get a 0. Okay, so that's just one step. Then we start the process over again. How many times, or no, actually, we drop the next number down, so we're looking at 8 here. How many times does 4 go into 8? And we see that that is 2. Multiply, subtract, and if our remainder is 0, then we're happy. That means that 32 times 4 is 128. This could be a place where we get a remainder. But again, we see how many times it goes in, multiply it, subtract it, drop it down. How many times does it go in? Multiply it, subtract it, drop it down. And do that as many times as is required. So let's actually get into this with some polynomials. Okay, so let's get our problem set up here. We have 4x cubed minus 7x squared minus 11x plus 5. And that's being divided by 4x plus 5. Okay, so here we want to take the first term of this thing that we're dividing by, is called the dividend, okay, or the divisor actually, and see how many times it goes in to this guy here. Okay, so what do we need to multiply 4x by to get to 4x cubed? Well, 4x times x squared will give us that 4x cubed. So let's remultiply it out. X squared times 4x gives us a 4x cubed. But then we also have to distribute it to the other thing there. So 5 times x squared is 5x squared. All right. Then we subtract this whole piece here, so be careful to distribute that negative. 4x cubed minus 4x cubed, that's going to cancel. But negative 7x cubed minus 5x cubed, that's going to give us negative 12x squared. Okay? Then remember, after we remultiply and subtract, we have to drop the next thing down. Okay, we subtracted the results there. We dropped down the next thing, and we're going to start the process over again. So we're thinking, what do I need to multiply 4x by to get a negative 12x squared? Okay, well, we definitely know that it has to be a negative to get the negative. And it looks like we need another x. Okay, so double check that there. All right, so remultiply that out. Remultiply that out. And it looks like to me we get negative 12x squared. And multiply this again, and we get minus, over here, 15x. Okay, so we're going to subtract all of that now. Okay. All right, so negative 12x squared minus a negative, remember that's going to make a plus, so this is just going to cancel out. And then this is going to make minus a negative, so negative 11x plus 15x. This is going to give us 4x. Okay, that's going to give us 15x. All right, last time, let's drop this down. Plus 5. Let's think really quickly. What do we need to multiply 4x by to get to a 4x? Well, that to me looks like it is a 1. Okay, so here, this would be plus 1. 1 times 4x gives us 4x. 1 times 5 gives us 5. If we end up subtracting those from one another, we get a 0, which means that it was a perfect divisor. So when we divide these together, our answer would be x squared minus 3x plus 1. Voila. Look back over that for just a moment and see if that makes sense to you. Okay, hopefully it does, follows the process. Now remember, we could always triple check our answer by multiplying this out, right? You could FOIL it out, combine your like terms. Let's try another example here. All right, so we have x plus 2, and we're wanting that to go into 6x cubed plus 10x squared plus x plus 8. Okay? All right, let's start the process over again. Remember, the question that we're always asking is always about this first term. This is only useful when we multiply back through. So what do I need to multiply x by to get to 6x cubed? Well, we're definitely going to need the 6. And we only have one x here. We need 3, so I need 2 more. Now that I've asked that question, I need to multiply it back through. So 6x squared times x will give me 6x cubed. And then 6x squared times 2 gives me 12x squared. But remember, I'm subtracting all of that. So 6x cubed minus 6x cubed, that's going to cancel. 10x squared minus 12x squared, that's going to give me a negative 2x squared. Let's drop down the x and start the process over again. So what do I need to multiply x by to get to a negative 2x squared? Well, I'm definitely going to need the negative 2 there. I only have one x and I need 2 of them, so I need another x. X times x, negative 2x times x, that gives me the negative 2x squared. Life is good there. So then we drop that down. Let's remultiply it out. Negative 2x times x is negative 2x squared. And negative 2x times a 2 is going to give us a minus 4x. Let's subtract all of this away. Negative 2x squared minus a negative, so that's going to make a plus. That's going to cancel these guys out. X minus a negative 4x minus a negative is going to make a plus. So this gives us 5x. Last time, let's drop this guy down, plus 8. We're looking to ourselves, what do I need to multiply x by to get to a 5x? Well, that's going to be a positive 5. So 5 times x gives us 5x. 5 times 2 gives us 10. But now I need to subtract that whole piece. 5x minus 5x is going to cancel. But 8 minus 10 is going to give us a negative 2. I know I'm done here because I don't have any variables left. You're done when there are no variables. So we have to now be careful about how we write our final answer. It's not just this. Our final answer is going to be 6x squared minus 2x plus 5. But then we have to take this piece right here and put it in our answer. So it's going to be minus 2 over what you divided by. So x plus 2. Okay, that's how you'd write your answer. Notice I have my whole thing that's on top of my quotient bar, then your remainder over your divisor. Okay? All right, let's try another one. we have x minus 2 dividing into 2x cubed minus 3x squared plus x plus 4. You're going to try the next one by yourself, but we're going to do one more together. So again, it's first term to first term. What do I need to multiply x by to get to a 2x cubed? Well, I'm going to need the 2, and I need a total of 3 x's. I already have 1, so I need 2 more. Once I've divided, now I multiply, so 2x squared times x gives me 2x cubed. Then 2x squared times a negative 2 gives me minus 4x squared. But remember, I'm actually subtracting that whole piece. So 2x cubed minus 2x cubed, that cancels out, thankfully. But here I have negative 3x squared minus a negative, so that makes a plus 4x squared. So that result there is just 1x squared. Then let's drop this next term down. I have plus x. And we're starting the whole process over again. So it's first term into first term. What do I need to multiply x by to get to an x squared? That's just an x. So now distribute it. X times x gives you x squared. X times a negative 2 gives you minus 2x. Let's subtract this. X squared minus x squared, life is good there, that cancels. X minus a negative 2x, that's going to give me a total of 3 x's because of the minus a negative. Then we just finally drop down our last term. All right, first term into first term. What do you need to multiply x by to get to a 3x? And that is plus 3. 3 times x is 3x. 3 times a negative 2 is minus 6. Subtract the whole piece. So this is going to cancel, 3 minus 3. But then 4 minus a negative 6 is a positive 10. All right, since we have a remainder, that's where we have to write that last weird little piece. It's not just this. So final answer is 2x squared plus x plus 3 plus our remainder over our divisor. Final answer. All right, at this time I want you to hit pause and I want you to try example 4. Pause and try example 4. Okay, hopefully you've had a time to go over this. Let's try it together. X to the 4th plus 3x squared minus x plus 5 divided by x squared plus 3. Ms. Cleveland, why did you make us do the hard one by ourselves? You're fine. It's the same process. The questions that I want you thinking to yourself is, what do I need to multiply this guy right here by to get to this number? Well, I needed 4 x's, but I only have 2, so I've got to multiply them by an x squared. X squared times x squared gives me x to the 4th. X squared times 3 gives me 3x squared. Well, when I subtract this off, this is going to cancel, and 3x squared minus 3x squared, that cancels. So there's nothing left there. I'm just going to simply drop down my negative x. Well, I can't multiply this by anything to get to this, right? The exponent is lower, so I know that I'm done. Okay, we can just drop both of these down at this point. When you end up having less exponents than your divisor, you know you're done. So the answer is x squared plus a negative x plus 5 all over x squared plus 3. So that was a little weird. But the only thing that goes into this whole is the x squared. This right here is just a remainder, right? We could, if we wanted to do this fully out, you can't multiply anything by this. So you could put a 0, but you're still going to just keep getting the same things here. So because this exponent is lower than the exponent here, we know we're done, and we just take whatever's left and put it over your divisor. All All right, at this time, you have a homework assignment with a substitute. When I get back on Wednesday, I am going to check your 12.1 and 12.2 combined worksheet, and I'm going to check your 12.3, okay? So please have that ready, and good luck.